Hello and welcome again to exam question 7 for permutations and combinations. So in the first question we have the 7 letters of the word minimum written on separate pieces of card, and we're selecting 4 of these cards at random. What's the probability that each card shows a different letter? Well, first we're going to write down all the different combinations of letters that we can have. Now let's take the top line to start with, M-I-N-U. Now we have 3 different M's to choose from for the M, but we also have 2 different I's to choose from for the I. So the number of ways we can pick M-I-N-U is 3 times 2, which is 6. Now in the next line we have 2 M's, and if we have 2 M's we could have M1 and M2, M1 and M3, or M2 and M3. 3 different ways. There's only one N in U, so there's 3 different ways we could have MMNU. On line 5 we have 3 M's and a U. Now we only have 3 M's to choose from, so there's only one way to do that. So there's only one MMU and MMN. However, when we get to MMMI, we have 2 different I's to choose from. So again, there's 2 ways to choose MMMI. When you've worked out every line, you'll see that there are 35 different ways to choose 4 cards. Now there is only one line where every card is a different letter, MINU, and there are 6 ways to choose MINU, so the probability is 6 over 35. Of course, if you use the combinations formula, you could also work out how many ways you can choose 4 cards from the 7, and we also get 35. Now part B asks for the probability that the 4 letters chosen contain at least 2 M's. Now I hope you can see that this is still a combination because it's only asked that the M's are present and not for the number of different arrangements possible. So the arrangements that have 2 M's are here, here and here, but we could also have 3 M's. That also qualifies, and that is this one, and this one. Now if we add up the number of ways we can choose the 4 cards for each of those scenarios, we get 22. So the probability is 22 over 35. So in the next question, we have 5 adults and 6 children at the cinema. Now they sit at random next to each other, and we want the probability that no 2 adults sit next to each other. So we need to find out how many arrangements there are where the adults don't sit next to each other. To do this, first we're going to place all the children in the seats with a space in between each one, and the adults can sit in any of the red spaces. Now when the 5 adults have been placed in the seats, there should be one free, and that will be eliminated, and then you have your 11 seats. Now the number of ways to arrange the 6 children is 6 factorial, and the number of ways to arrange the adults, well, we have 7 seats and we've got 5 adults, so it's 7p5. So the number of arrangements where the adults are not together is 6 factorial times 7 factorial divided by 2 factorial. The total number of arrangements for all 11 people is 11 factorial. And the probability is the arrangements where the adults are separated divided by the total number of arrangements, which is 1 over 22. In part B, we have the same scenario but with 3 adults and 8 children, but we're going to do it a slightly different way this time. So if we write down the adults and children like this and then group 2 of the adults together, we know that if those 2 adults are together, however we rearrange it, there will always be an adult together. Now we have effectively 10 items to rearrange, so the arrangements is 10 factorial, but then we have to times it by 3 because we could group the 2 A's and the single A in 3 different ways. You can have A1, A2, A3, A1, A3, A2, or A2, A3, A1. But then we have to times it by 2 as well, because the 2 that are grouped together, let's say for instance it's A1 and A2, you could also have A2 and A1, you can swap them. Now the total number of arrangements again is 11 factorial, so the probability that the adults sit together is 10 factorial times by 3 times by 2 divided by 11 factorial, which is 6 over 11. And as probability always adds up to 1, the probability that the adults don't sit together is 5 over 11. Right, I'm going to have to finish here because I'm trying really hard to keep the videos short for you. Like and subscribe, always appreciated. See you soon.